now our last conversation about manufacturing in the digital age. And for that, I'm delighted to introduce William King, the Chief Technology Officer at UI Labs, and KG Rajan, President of Alsip MiniMill. It's a paper mill in Alsip, Illinois. And Steve, you're back?
I'm back.
You are back.
Normally you give me time to change my socks. So now we're going to talk to the other part of the equation, really about making things, the technology, which can include people, I guess. But on this, for the purposes of today, we did our people part already. Now we're going to sort of talk about other parts of the manufacturing equation. And Bill, everyone is sort of looking at how great this manufacturing institute that you've brought, that you've helped initiate here is. How big is it? 150 million?
200.
200 million. Sorry to shortchange you a little bit there.
It's okay. Yeah.
200 million. So and 70 million from the U.S. government.
80 from the U.S. government.
So somebody fed me the wrong number. So 80 million.
Yeah, that's right.
And then the rest from the private sector.
That's right.
So when you sort of did this and sort of helped create this, why was this considered to be something worthy of that level of investment here?
So manufacturing generates more data than any other sector of the economy, any other industry, which is really amazing to think about. Manufacturing generates more data than healthcare, more data than government, more data than retail, finance.
More data than all our Fitbits.
Absolutely, yeah.
Which I left at home, unfortunately. I'm not getting credit for any of my walking here today.
When we talk to manufacturing leaders and you ask them how much of your data do you use, they report very little of it, 1%,
Really?
2% on average. There's no company that will report more than 10% of the data that they gather they actually use. So this is a huge opportunity. The data is an asset.
So your job is to look at the data and figure out how it can have greater applicability, particularly in logistics and transport, or is it across the board?
So we've envisioned digital manufacturing as something that goes across the entire product lifecycle. Everything from designing, making, supply chain and sourcing, delivering to your customer. Even the manufactured product lives on and generates data as it's being used by your end customer.
Rajan, you're in the mini mills business, or you've been. How many mini mills have you made?
This will be my 6th one.
So, as somebody who's never met somebody who's a mini mill maker, what are we talking about? Like, make it real for us.
Well, there's a couple of things. One is in manufacturing, bigger is better, is what people in economics 101 they teach you that, and mini mills, as you know, in the steel industry, prove that that's not the case. The big mills were shutting down, and the newer mills, the new cores of the world came online.
Right. Mm-hmm.
Same thing in the paper industry. As a matter of fact, interestingly, the Alsip mini mill that I'm now rejuvenating came to an end because of digitization, because they were making fine paper or magazine paper. And there was no longer a bigger market. That market was shrinking.
Tell me about it.
As a result, they shut it down. And we came in, and our market, which is in the packaging business, has been growing, not drastically, but it's been growing thanks to the internet double packaging and all of that that's going on. So in a sense, that's what drove us to do that. And geography is no longer an issue. I mean, think about why, if you take away geography and bring in automation, it doesn't matter whether you make a product in China or you make a product in Chicago. The cost factors are taken out if automation levels are brought up. So rather than sit back here and say, well, we're going to give up the market to someone else overseas, we said, why don't we make it right here? In fact, we are rejuvenating the mill, and we're bringing back everybody, the same workforce, with a little bit of different training programs and things of that nature, but high levels of automation.
So you're bringing the same workforce back to the plant that was making magazine paper, and now they're making packaging material, and you had to train them. So walk us through. I mean, let's say I was an employee at the previous plant, and I made magazine paper, et cetera. What would be, how would you marry, what would my skills upgrade to look like?
Well, the technologies are quite different, but the machinery, a lot of the machinery is the same.
Right.
So you've had the basics. In fact, we've been quite pleasantly surprised at the high levels of knowledge a lot of these folks have had. And you just got to give them the new set of skills, that computerization, As a matter of fact, to give a plug-in for Siemens, I've been buying Siemens equipment for almost all of this in Alsip. I guess that's where they asked me to
Maybe they'll
join
give you a
this.
discount now.
Yes.
Yeah.
But the point is, you got to teach them how to operate a lot of this based on the new technologies. And you talked about the data collection. That's a very important part of it. You've got to get to know how these things talk to each other, all of these components. And one of the biggest problems you have in all of these is the multiple different groups of people who really don't talk to each other, you know.
Right. So that's one element I want to talk to both of you about, because we've been talking about workforce development, people, upgrading skills. There's a part of me that wonders 10 or 15 years from now, 20 years from now, maybe even 50 years from now, how much people are a part of this discussion. How much, when you have data, you have the Internet of everything, you have machines talking to machines, and you have data being applied correctly. Is there an element in which all of the work we're putting into workforce today becomes irrelevant because the manufacturing sector has just moved beyond people?
I think manufacturing digitization makes knowledge workers more important. And so manufacturing workers of the future will be knowledge workers. They will be people that know how to use data, how to ask questions of data, how to visualize data in a manufacturing environment and make good decisions.
And so they remain in the picture. Rajan, do you have a thought on this?
Yeah, I mean, the idea of lights out factories of the future, where human beings have no work to do except stay home.
You call them a
and eat
lights
pizza.
out factory?
Yeah, you know.
'Cause you don't need light.
Right.
Huh.
You basically turn off the lights and the widgets are being produced. Has been talked about I'm sure, in academia for a long time. And that's the fantasy of the future. The real thing that's happening today.
Or the nightmare.
The nightmare. You sit at home and order pizza all day. And you don't want to be in that situation.
And how do you pay for the pizza?
Well, it's a digital thing anyway. It doesn't matter. So that's the fantasy of the future. The real thing that's happening today is an upgrade of the skills of the adult workforce. What I see is a real need there. There are folks who went to high school a long time ago. I don't know if they finished high school or not, but we have found folks who are not able to actually read. And I'm surprised at that because, you know, in this day and age, to find a high level of illiteracy in the U.S. workforce is just amazing to me. I mean, I come from India. I've been used to illiteracy a little bit there in the past, but the fact that I'm finding it here in Chicago, that amazes me. So we have got into programs where they can go in and learn and do things. And of course, there's also the adaptation of the immigrant population. The whole world is becoming a global village. So all of that poses a lot of challenges in this business.
Now, you shared something with me in the back room, which I found fun, which was you have, 4 children also?
Yes, I do.
You have 4 children, and you had not, until recently, convinced any of them to go to manufacturing. They thought that was a terrible, terrible course, terrible direction to go in. And I'm interested in just sort of that as a metaphor for the challenges we've been discussing in part today, that in reviving manufacturing, you've got to do a little bit of marketing to get people in, and you seem to have just succeeded with at least one of your kids.
Yeah, he went into .com to begin with, and you know, you get the excitement of starting companies, and I've always told young folks that they should try.
I mean, were you trying to get your kids to go into manufacturing and said no, Dad?
No, I never stopped them from going into manufacturing. Neither did I encourage. I wanted them to
you didn't encourage them either.
No, neither. I didn't do any one of those. I said, well, if you're interested, you're welcome to join the party. But they found, I mean, the .com business or the technology business, as they say, is very interesting and fascinating because you join and next thing you know, you get your benefits and shares and this and that all looks good. But I think over the long run, I do believe manufacturing is a great place to be, even to make money. You know, you don't have to all go to Silicon Valley and
one of your kids is now working with you.
Yes, he is. He left the .com business after trialing out a few things and this and that, and he made a little bit of money, and then he joined over with me, and I showed him the way, and he finds project management, executing these large projects, and doing stuff, real things with real people, you know, construction folks and workforce. He finds it very fascinating and interesting. As a matter of fact, he's right now in Alsip, got his work boots on and right in the middle of the thick of things. So
I'm glad he's doing something productive. Bill, tell us a little bit about the person who's working his or her way through your institute. What's the profile of the people that you're attracting and bringing in? And are any of them here?
I think so. Some digital manufacturing folks in the audience.
Oh, cool.
Got a bunch of folks
wow.
here. Hey, guys. It is a really exciting time to be a technology person, a young person just starting your career and interested in manufacturing. We know what it looks like when there's a sector of the economy that becomes digitized. There's all kinds of changes that occur and lots of opportunities for new entrants, people that want to start companies, develop new technologies, bring new ideas to bear. So I think all of that is available now in manufacturing as well. These are the kinds of people that are coming to the Digital Manufacturing Institute. They're very excited to bring new technologies and new business models to bear on the manufacturing sector.
What's been your biggest screw up so far?
It's hard to start a new thing, and the bigger the thing is that you're trying to start, the harder it is. So just trying to go fast and have an impact.
Well, let me ask you too before I go to the audience and ask. I want to again. I'm intrigued on how you get the equation right for a healthy sort of manufacturing, partnered with community colleges, partnered with workforce departments, partnered with the state or federal resources, partnered with the private sector, and of course you have to have people in the middle of this who have trust and faith that will all add up to something. And we had the mayor here today, which I think he had some really deep insights into what that equation ought to look like. Again, to the two of you, if you were to tweak the equation, if you were to look at how you might shape the stakeholders, change what your resources are, what would be the thing that you would think would be most useful to shift one way or another to improve the economic and manufacturing health of this region? Bill?
I'll talk about the educational side. So, as you think about the skills that every worker will have in the future, digital capabilities is one of them, the ability to understand data, how it works.
Literacy?
Digital literacy, absolutely, yeah. And I would put that both at the high school, community college level, and the universities as well.
Do you see it happening?
It is happening. It could happen faster for sure.
Mm-hmm. Rajan?
I would echo the same sort of thing, except I would emphasize more on the basic math, physics, and chemistry.
You would emphasize more?
Yes, definitely. I think in high schools and so on, there's been a real trend amongst a lot of the kids from not wanting to be, when they enter into the high school programs, they don't look at math and physics and so on as really the place to make money. Instead, they go off on a tangent without having the basic math skills, the basic physics skills, the basic chemistry skills, and so on. So I think that's the trend I would definitely reverse. I would go into these high schools and emphasize that's where it is. And if I'm an employer, before I employ somebody who really didn't get into that heavy-duty stuff and went to only the soft stuff, if you will.
Did you have a hero when you decided to go into this? Did you have a math or chemist or physics hero? I mean, Elon Musk comes to mind as someone who's become a pop culture figure who's essentially a physicist.
That's a great example.
And are there others? Is that an important part of changing the game of how people think aspirationally about what they want to do?
Absolutely. I just think that somebody like that, is Elon Musk and people like that, and dreaming of wanting to go to Mars has got to be in the psyche of every child, if possible.
Bill, are you the big data hero?
I think Elon Musk is a great hero.
You're so self-effacing. It's interesting. But do you think there are heroes in data? Would that help in your world of thinking about digital manufacturing, bringing somebody around?
I think a key message for young people is that manufacturing is a technology industry, and all of our tech heroes of the day, we can do all of that for manufacturing. There will be a Facebook for manufacturing. There will be a Tesla for manufacturing. This is what it's going to look like over the next couple of decades. It's hugely exciting.
Well, let me go to the audience here for any comments or questions. Thoughts, reactions before I call on you? Yes, my friend right here from the university. Hi. Yes, let me bring a microphone right to you.
My name is Marius Stan. I'm a computational. Did I do anything? Oh, okay, at Argonne National Lab and a fellow at the University of Chicago and Northwestern University. Now, it used to be that computation was something that people with the use on very large scale on big computers, high performance. But now, at universities and at some companies, there are small clusters of computers that are being used. Some people do their computation on their laptop, on workstation, or even on a smartphone like this one.
Sure.
What kind of software, what kind of computational platforms do you use at your institute and at your company?
So if you go into a modern factory, it's amazing. You will see a programmable logic controller that's 30 years old. It's connected to a dot matrix printer that's printing out data about the manufacturing process. And the person operating the machine...
Still today. Yeah.
And the person operating the machine will be doing something on their smartphone, which has millions of times higher computing capability than the equipment that they're interacting with. So this is huge potential for disruption as we can leverage the connectedness and the intelligence that people are bringing into the factories with them every day.
Can I just ask you real quickly at Argonne National Lab whether your processes are dramatically better than the ones that are in mainstream manufacturing companies?
Of course they are. Now, in some areas, we do employ some of the most advanced state-of-the-art types of software, and we do run on one of the most powerful computer in United States and in the world. But for some applications, one does not need to use so much computational power. And rather than high performance, high power computing, one can use a smart, more intelligent way of doing computation. And I think that doesn't have to be necessarily at a national lab or large university. It can happen very well at a company. And the example I would like to propose to you is materials design, which is a project I'm working on. How to create better materials by running first computer simulations and perhaps reduce the number of experiments one needs to do, the number of trial and error or cook and look approaches that we need. If we could do that, not only we could get better materials, but we will save time and money, which is something I bet interests.
You guys ought to have a drink together, and maybe you too. Yes, right here in the front. And you're my friend in 3D printing, right? Yes.
Hi, Tanya Berger-Wolf, faculty in computer science at University of Illinois, Chicago. University of Illinois, Chicago in general is a huge data hub. You're bringing up the other side of data to manufacturing from University of Illinois, Urbana-Champaign. That's okay, we're friends. So my question to you is, particularly in manufacturing, the separation between different companies is even stronger than we talk about the separation between the different fields in academia. How do we use data to bring the different companies, different industries together and to really get them to leverage that information that all of them have when there's so much protection and of intellectual property, of those data, and so much resistance to open it across industries?
Before you sit down and before you go and before both of you answer, how would you fix the problem?
I would first, of course, to show the benefits of opening data, and there's a lot of data that can be open already, and a lot of companies and industries, in my experience, just don't realize that the data are already open. Second, to put infrastructure in place where the data can be accessed and analyzed without actually, across industry, without opening the data to each other. So there are mechanisms for doing this. And finally, to put the benefits, probably first and foremost, to show the benefits at the very huge scale of doing it. And starting small with different companies or different industries, but scaling it up as the benefits become evident.
Fascinating. Bill, where is she right and where is she wrong?
I'll say that one of the most interesting gaps to me is the gap between people that design things and the people that make things. And so, decades of offshoring and outsourcing has created this structure to the industry that these two groups of people don't collaborate. Now, what technology does is it lets these groups of people collaborate in new ways. In our institute, we're demonstrating a cloud-based collaboration in supply networks that allows designers and makers to work together to do things faster and to really demonstrate the business case for digital manufacturing.
Rajan.
As far as the data sharing is concerned, within a paper mill, for example, we have process variables, the temperature of the water or this or that, different things, that we correlate all of that to the end product itself. When you see that brown box that you use, it's the result of probably 10,000 variables that we correlate to this. Now, those sorts of things usually goes on in the back room, and with engineers and so on, those who have graduate degrees and that sort of thing. But in a real manufacturing facility, the number of folks with a graduate degree, you can probably count them on one hand, typically in a paper mill. So the industry is not set up into a research thinking mode. That, I would say, is the fundamental problem. And I, for one, I've tried to inculcate that in some of the younger folks coming in. And that's why I think the millennials will fit in nicely into the manufacturing business. And I'm always looking for millennials, including my kids.
There are a few here that may be looking for a job.
Absolutely.
And we still have a drink with you later.
We still haven't filled one of our electrical instrumentation technician, for example. That's been almost a year. We've been looking for six people, and we've filled only 5 so far.
And let me just to wrap up, and she asked a very interesting question about the proprietary nature of sort of data hoarding, that for whether it is intellectual property issues, whether it's that people are afraid that they're giving away something they shouldn't be giving away. See this a lot in the healthcare sector, dramatically in the healthcare sector. You're on the front line of business. Do you think there are platforms out there that would create greater confidence or help seduce manufacturers and players that hold this data to cooperate? What would that thing look like in reaching you, for instance, if you were?
Yeah, I mean, there's for example, if you take a company like Clemons, they can have access to our process variables. Exactly what's going on in the mill, if cybersecurity is not an issue. But the problem is, if they got from 10 different people, all our competitors, and they were able to create a level of knowledge base that then ensures the depth of one or the other, because as their own knowledge, the central collective situation where they are collecting all this information, so they're starting to see, well, this mill is so much better than this and this and this, and pretty soon you'll have a level of competitiveness that doesn't really allow you to survive. So while collaboration in theory is a great idea, the fact is it is competitiveness that has brought out the best in this world, not collaboration. So at the end of the day, you want both, but I would err more on the competitive side than on the collaborative side as a businessman.
Too much sharing can be deadly, is the message here. I want to thank you both. Bill King, who is founding Chief Technology Officer of UI Labs and the Andersen Chair in Engineering at University of Illinois, Urbana-Champaign, and KG Rajan, President of the Alsip MiniMill, and apparently many other mini mills. So thank you both very much for joining us today. Thank you.
Thank you.
Thank you.